What is glitching? The presentation? Is it still glitching? All right, let me stop it and start it again and see if that helps. So is it not there when I have the presentation off like this? Is it fine right now? Okay, let's see if I can do the presentation again. What about now? Is it presenting now? Okay, all right. I was getting a little worried. I'm like, how are we going to do this if they can't see it? I mean, I had some things going in my head to figure it out, but what we're moving into right now is we're in chapter 5 still, right? But we're doing chapter 5.4. And what we're talking about is the sum and difference formula, which means basically the formulas for adding and subtracting trigonometric functions, right? And they look pretty complex. Like I have sine of u plus v equals sine of u times cosine of v plus cosine of u times sine of v, right? They all look a little crazy. The good news is you don't have to memorize these, right? You can always use this. I will post this into PowerSchool as well, the sum and difference formulas here in front of you so that you have it when you're doing your assignment. But for right now, I've just got it right up here. That's the one thing I did forget to do earlier was to put that in. I'll probably put this unit circle in too, just so you don't have to go looking for it. So what we're going to talk about is how to play with these a little bit, because sometimes we get signs of things that aren't as easily identifiable. And I think we had a little something with one of those where we had, I forgot the word denominator there for a second, where we had denominators of 12 and we had to, but we wound up multiplying it and being able to reduce it, but we can't always do that. So I think that the best way to show you how to do any of this is to just do examples with it. There's not a lot of explanation necessary when you see the examples. So I'm going to go ahead and do a few examples so you can kind of see. And we will be coming back to this chart a lot and back to the unit circle a lot. So in our first example, we're going to be asked to find the exact value of sine pi over 12. Now, if this was pi over 6, we could go right up to our unit circle and we could go, well, here's pi over 6, and we know that it is the y value, so it's 1/2. But we don't know what sine of pi over 12 is. But we can figure it out by breaking it down a little bit. If I look at pi over 12, I can break that down into pi over 3 minus pi over 4, right? Because if I think about this, I could go, well, 3 times 4 equals 12, right? I want it to be my bigger over my smaller. So even if we don't know the minus yet, we could go, well, 3 times 4 equals 12. So what do I have to do to get a common denominator here? I would have to multiply this times 4 over 4, and this times 3 over 3, right? This would give me 4 pi over 12 minus 3 pi over 12. and I would get what I was looking for with pi over 12. And this is what I mean when I say you have to kind of think about these a little bit. Like, how can I break these down into recognizable pieces that I can just go to my unit circle and find these values, right? So once I know that I can use pi over 3 minus pi over 4 to have that be equal to pi over 12, then I can just start using these formulas. And the formulas aren't super complex. They just look a little harder than they actually are, right? And if we go up here, I have pi over 3 minus pi over 4. So I can call this sine of pi over 3 minus pi over 4, right? It is equal to sine of pi over 12. I just broke down that fraction into something that I can work with, right? So I need to go and get the formula now for sine of u minus sine of v, right? I have sine of something minus sine of something else. And right here, I can see that it equals sine u times cosine of v minus cosine of u sine of v, right? Technically, this is our u because it comes first, and this is our v, right? And so when I write this, I'm going to write over here what it was. It was sine of u minus v equals sine of u times cosine of v minus cosine of u sine of v. And so when I write this now, and I've got sine of u, well, that's sine of pi over 3 times cosine of v, well, that's cosine of pi over 4, minus cosine of u, well, that's cosine of pi over 3 times sine of v, which is sine of pi over 4. And the reason that this helps us is now I can just look here and see what each of these equals, right? We've got sine of pi over 3. Well, pi over 3 is up here, and sine is our y value. So we've got radical 3 over 2 times cosine of pi over 4. Well, pi over 4, whether it's sine or cosine, is going to be the same. It's going to be radical 2 over 2. Minus cosine of pi over 3, well, that's going to be our x value at pi over 3. So that's just 1/2. Times sine of pi over 4. So we're going to go back to pi over 4, and we're going to go to our y value, but it doesn't matter because it's pi over 4, and they're both the same. Radical 2 over 2. And now we can just solve it, and we will get the solution, the exact value of pi over 12. Sorry, I keep hitting that mic. So radical 3 times radical 2 is radical 6 over 2 times 2, which is 4, minus 1 times radical 2, which is just radical 2 over 4. And we can put these together, radical 6 minus radical 2 over 4. So really, it's just finding things that you can plug in to make it work. We didn't know what pi over 12 was right off the bat, but we could break it down into smaller fractions and figure out our exact values that way. Did that make some sense? It's not the only one we're going to look at, but I just want to make sure you guys were kind of able to follow with that before I move on. No, it doesn't break down any further because you can't combine, since we're not multiplying, we can't combine the radical 6 and radical 2. And you can't divide into something under a radical to reduce that fraction, right? So even though everything here is an even number and you'd think you could divide it by 2, you can't divide by 2 under a radical like that. Good question, though. So this would definitely be your complete and total solution. It's funny because the next problem that I have is going to have the same exact solution, to the point where I'm like, did I just solve the same problem again when I was writing it out earlier? But its way of solving it is completely different. Like, we're moving in a whole different direction with how we solve it. So with this one, we're going to use, I feel like I should change colors. When I move to a different problem, I should change colors. Let's go gold. It makes me feel rich. We're going to again find the exact value of cosine of 75 degrees. I liked this problem because you guys are so much more used to dealing with numbers than you are with radians, right? With the fractions of pi. So I thought a problem like this would be good for you because you can kind of see a little bit more clearly how we break this down. So we don't know what cosine of 75 degrees is. If we look here at our unit circle, right, everything we're dealing with is 30, 45, 60, 90, 120, 135, right? We don't know what that is. But we can break down cosine of 75 degrees to equal cosine of 30 degrees plus 45 degrees, right? Which equals 75 degrees. And we can figure that one out, right? Because we know what all of the exact values are at 30 degrees and at 45 degrees. So if we look at this now, let me see if I can go bring this image down with us too so we can see. If we look at this, we've got cosine of, we'll call this u and this v, right? So we have cosine of u plus v, right? And we can just use that formula. Cosine of u plus v equals cosine of u times cosine of v minus sine of u times sine of v, right? So we can look at those now and know what they are. And if we look at cosine of u, well, this for us is just going to be cosine of 30 plus 45. So we're going to have cosine of 30 times cosine of 45 minus sine of 30 times sine of 45. And so now all we have to do is go up here and find out what those are. Well, cosine of 30, well, that's our x value at 30 degrees. So that's going to be radical 3 over 2. Cosine of 45, everything at 45 is radical 2 over 2, except for tangent, because those will have to be multiplied out. So we've got radical 2 over 2 minus sine at 30. Well, that's our y value at 30 degrees. So we've got minus 1/2. Sine of 45, everything at 45 is just radical 2 over 2. And now all we have to do is put these numbers together again, right? And we wind up with radical 3 times radical 2, which is radical 6 over 4, minus radical 2 over 4. And again, we are left with radical 6 minus radical 2 over 4. So our examples wound up having the same solutions, but it should give you a pretty good picture of how these work, right? Anything we get, it's going to give us that little formula, right? sometimes we have to manipulate things to make them work into the formula. And they're not always going to be this, I want to say simple. I know the first one seemed a little bit more complex because you had to think a little harder about how to break down that fraction. But this one kind of made a lot of sense, right? 30 plus 45 equals 75. Those are the kind of numbers we're used to dealing with. Did this one help out a little bit to understand the first one a little better too? Good. So now that you understand, we're going to move into something a little bit more complex. The good news is this is the last example that I did for you guys, which means our video is not going to be a whole heck of a lot longer. I like doing these videos this way when I do the lesson, because then you don't have to go through an ed puzzle or anything and ask questions. You can just scan to the part you want to know about. This one, the question is going to be a little bit more long-winded. So I'm going to do it in orange. So this one still wants us to find the exact value. But this one is saying of sine of u plus v, right? But it's saying that given sine of u equals 4/5, right? It's also giving us a little piece of information. It's saying when zero, what did I do there? Because I can't read my own handwriting. Oh, 0 is greater than u, greater than pi over 2. So all this is saying right here, it's saying our u is between 0 and pi over 2. It just means it's in this first quadrant, right? It is also saying, and cosine of v equals negative 12 over 13, where less than pi, right? So now they're saying that u is in this first quadrant, but v is pi between pi over 2 and pi, so v is in this second quadrant. So up here we have u, and here we have our v's, right? But it's not giving us all the information we need, because clearly we need to know sine and cosine of u, and we need to know sine and cosine of v. And right now, all we know is sine of u equals 4/5, and we need to know what cosine of u equals. And we know that cosine of v equals negative 12 over 13, but we need to know what sine of v equals. And this is going to take us back a few sections, right? Where I know that if I have sine of u equals 4 over 5, right? That is like saying that I have a triangle, right? Sine is opposite over hypotenuse. Well, here's my hypotenuse. We know that's 5 and that is 4, but we don't know what this is yet. So we still have to use that distance formula. We can go 5 squared minus 4 squared equals whatever this is, right? So we're going to have 25 minus 16. So we're going to have the square root of 9 equals 3. So we know this one is 3. And with that, I can tell you that now cosine of u, I should put in that this is our u, right? Cosine of u now we know is 3 over 5, right? Because sine is opposite over hypotenuse, right? And cosine is adjacent over hypotenuse. But we have to do that for this other one as well, right? And we know that on this triangle, We know that our hypotenuse is 13. That should be a right triangle, but it changed it on me. And our cosine is adjacent over hypotenuse. So what we're saying is that this right here, we're going to call it 12. It's negative 12 just by location, right? Because we know that it's on that second quadrant. So we had to have a negative x value. But we need to figure out what this is right here. So we're going to do the same thing. We're going to take our hypotenuse, 13 squared minus 12 squared, and we are going to get 169 minus 144. And when we subtract those, we get the square root of 25, which is just 5. And once we have this information, this whole thing becomes pretty easy. So now we have, for sine, we have 5 over 13. Right? And now all we have to do to solve this, to find our sine of u plus v, is to plug in those pieces, right? We know that sine of u plus v equals sine of u times cosine of v plus cosine of u times sine of v, right? And so we just need to go find those pieces now. So if we're doing sine of u plus v equals, sine of u we know is 4/5, right? Times cosine of v, well, we know that cosine of v is negative 12/13. Plus cosine of u, which I covered up with that right there, is 3/5, times sine of v, which is 5/13. This is what I mean. Once we find all those pieces, we know all the information. Now it's just plugging it in and solving this. 4 times negative 12, well, that's negative 48 over 5 times 13, which is 65. Plus 3 times 5 is 15 over 65. And we are going to wind up with negative 13 over 65. Not reducible, I could tell right away, because 13 is a prime number, so there's nothing we can divide into it. And this is our exact value of the sine of u plus sine of v under those parameters. So you're not always going to be using your unit circle, right? Sometimes you're going to be given things and you're going to have to do a little deciphering. What did we have to decipher? We knew that sine of u was 4 over 5, so we knew that our opposite side was 4 and our hypotenuse was 5, so we could find the other side of that triangle. If we looked at that in terms of a graph, this would look like, right, it would be a right triangle that kind of, sorry, it's kind of hard to draw, right? We'd have a right triangle right here, right? This would be 4, this would be 5, and this would be what we were looking for, was our 3. If we were doing it with this triangle, we know that that's in quadrant 2. And so what we would be looking at is something that went kind of like this, right? And this would be 13. This would be 12 this time, because it would be our adjacent, and we would have to be figuring out what this one was, which we discovered was 5. Just to kind of get an idea of what that looks like in a graph. How do you feel about that? Do you feel like you can kind of grasp what they're asking for in this? Okay. Keep in mind, the only thing that made any difference here with our signs was directional, right? And when we plugged them in at the end. So if they're giving you values it's a little bit easier than having to go find them yourself or having to break down something and guess at the breakdown. But you can always find something you're used to. I highly recommend when you do these problems, I'm going to put both of these into PowerSchool right now, but when you do them, have these open so you can see them, right? Don't try and do this from memory. I have been doing these things for years. I can never memorize the sum and difference formulas. Just never have been able to. And I've been doing these for, I don't even know how many years at this point, right? This one, I could write a unit circle out in my sleep, but, and if you were actually in person in this class before you left my class, you would be able to write a unit circle out in your sleep, but it's hard to translate that online. But you would get quizzed every single class period on the unit circle and putting one together. Because it's like a 5-minute thing by the time you get it. One day you would wake up in the middle of the night and you'd be like, oh my God, why am I like putting the unit circle together in my sleep? But you guys have missed that luxury. I'm going to stop recording because that's pretty much all I have for you today.